Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today to learn Fusion 360 or die trying. What I need you to do is go pour yourself a nice cup of coffee, fire up Fusion 360, and get ready to learn some really cool stuff. What we are going to learn today is very, very important, and it's the concept of parametric design. And if you come from the electronics world like I do, a little bit more of programming and a little bit more of circuits world, this concept of parametric design is maybe something that you're not really familiar with, but it's probably the most one of the most powerful and one of the most important things that you need to know about mechanical design. And to kind of give you an example of what parametric design is that when we created this eyeglass holder in lesson number 2, we just sort of went in and drew things and dimensioned them and extruded them, and it's sort of like doing this and then doing this and then doing this and doing this, and then we ended up with a design that wasn't very thoughtful as far as making it easy to edit. And you end up in a situation that you have something that if you wanted to edit it, it's very hard because it messes other things up, and then it's almost like you just go back and it's easier to redraw it than try to fix it. And so we're sort of in this world now of you can design something, but then if you really need to edit it or you really need to adjust it, it's almost easier to go back and just start completely over. So what we're going to do today is we are going to learn how to design using parameters and using design intent. Okay, the easiest way to understand parameters, just as maybe as an introduction, would be if I said that a parameter is a little bit like a variable. And so instead of going in and putting numbers in, like I want this 3 and I want this 5, we're going to be putting parameters in, like I want this length and I want this width. And so that's the simplest way that you could think of parameters. It's designing based on variables. But it's a lot more than that, and it's a lot more important than that. What it is designing those variables in such a way that you create something that gives you the flexibility to edit it, but constrains you such that you will always end up with something that works. And so, like, let me give you an example. Like when we designed this in lesson number 2, we sort of just put a dimension here of 42 and a dimension here of 32. Okay, so if you were going to use parameters, you would say that that's what? Well, you could call it length and you could call it width. You know, this is width and this is length. Right, so you'd have 2 parameters there with what you're looking at here. Well, this is the top part. You also have a bottom part. Okay, and this is very, very important. Very important. So this is what I want you to think about, because this is like the essence. This is like really getting at the essence of parametric design. So I have a top and I have a bottom. Would I have 4 parameters or would I have 2 parameters? I could just say top width, top length, bottom width, bottom length. I could have 4 parameters, right? Or would I just have 2 parameters? Okay, this is design intent. What is it? I might want this taller, I might want it shorter, I might want it fatter, I might want it thicker, but what do I always want? I always want it to fit together. So because I always want it to fit together, how many parameters would I have for this? I would have 2, length and width. That way if you change one, it's always going to change the other one. Okay, so you see, putting in parameters is more than just changing out constants with variables. It's building in an ability to make it very easy to edit it later. You want to give yourself great flexibility in how you can edit it, and I guess really it's better to say customize it, how you could customize it later. Right? A person might come in with different glasses, and it might need to be bigger, and it might need to be shorter, and it might need to be all these different things, but what always is true? It should always fit together. Okay, so what we're going to do is we are going to go in and we're going to design this again using parameters. Let's review some very important things that we've learned. What have we learned? In the sketch dimension, we're going to win or lose the battle of 360 at the sketch level, at the 2-dimensional level. And when we are at the 2-dimensional level, what 3 things are we deliberately mindful about? Number 1 is dimension. Okay. Number 2 is position. And number 3 is constraints. And if you look at our earlier videos, we have talked about dimension, we have talked about position, and we have talked about constraints. Okay, today what we're going to do is we're going to show you how to put a 4th thing in there, and that is parametric design. But parametric design is still very much tied to the first 3. It's just you use parametric designs to make those first 3 things work for you as opposed to against you. Okay, so let me get out of your way. Enough of this nonsense talking, and let's start a new design. So we're going to come in and say new design, and then where do I like to draw? I like to draw in the XY plane, and so I'm going to say create a sketch, and X is red, green is Y, so I'm going to click on this plane and I am ready to draw. But we're not going to draw. We're going to stop and we're going to think about our design in terms of parameters. So how do I enter parameters? I come up under modify, I come down to change parameters, and you get this window pop up, and you can see that you don't have any parameters because we're just starting with a new design. So the way we define parameters, we come under user parameters, we click the little plus, and now we can enter parameters. What's the first parameter that I should enter? If you think of this as a rectangle, I'm going to think of it in terms of width. So I'm going to say width, and if you were here for lesson number 2, you remember we like that width to be 42 millimeters. This is a variable. We can fix it later, but we're giving it our initial parameters. And then our length was what? L-E-N-G-T-H. Our length was 32. Okay, and so now I've got 2 parameters, length and width. What is another parameter that I am going to need? I'm going to need what? Height. All right, I'm going to need height. And this is where we've got to be really, really deliberate. Okay, so I'm going to show you this. What you got to see is when this thing fits together, right? When this thing fits together like so, this is the bottom height, right? The bottom height is from here to here, from here to here. And then this is the lip height, all right? Similarly, the top height is from here to here, and then that is the lip height. And we've got to keep that in our mind because you want, right, it's this height, bottom height, plus this height, top height, is what your total height is, all right? And then built into that then is this idea of lip height. So let's add those 2 parameters. I'm going to have bottom height, and the bottom height is going to be 100, okay? And then I'm going to have top height, and the top height is going to be 20. Okay, these are just our initial parameters. Okay, so then it's going to fit together like that. Bottom height, and then from here up is top height. Now, if you think about lip height, do I have a bottom lip height and a top lip height? You see, this is the essence of parametric design. Is that going to be 2 variables or 1 variable? What is one thing with design intent that I always want? I always want it to press fit together, which means what? The top lip height and the bottom lip height need to always be the same. Now, it could be tall, it could be short, but it always needs to be the same. So do I use 1 variable or 2 variable? I use 1. We're just going to call it lip height. And this is taking a little while, but you can see I'm doing a lot of talking. Man, if you do things this way, it's just as fast, but you're just being more thoughtful as you design. And so let's make that 20. Okay, so we're going to make that 20. Now, what other parameters? So I have the heights, I have the lengths and widths. What is one other parameter that you can think that I need? I need the wall thickness, right? I need the wall thickness. So I'm going to do another parameter, and I'm going to say wall thickness. And what are we going to make that? We're going to make that 2 millimeters. All right. So that's the whole wall thickness, you know, here in the thick part. But what else do I have? I have a lip thickness, right? The thickness out here in this thin region. How thick is that? So I'm going to need to make, and then that lip thickness is the same as this lip thickness. So do I have one or two parameters? I have one because I want it to be the same. And I don't want, a person could mess it up where, you know, it wouldn't fit if you got those things wrong. So I want it that as you edit your parameters, your model is always going to work. And so what are we going to call this? Lip thickness. And then we're going to say that that is 1. Okay. I want you to stop and think. I want you to stop and think about how this works. Is that smart, what I just did? Is that smart? What if I made the wall thickness 4? Well, then I want the lip thickness to be what? 2. So think, is lip thickness, with my design intent, is it a dependent variable? Does it depend on other variables, or is it independent? Like I could just make it whatever I wanted. I can't make it whatever I wanted. It's dependent. It's dependent on what? It's dependent on wall thickness. I'm sorry, let me get out of your way. It's dependent on wall thickness. Okay, so really, lip thickness needs to be what? It needs to be wall thickness divided by 2, because if I just put it in like this, if I change the wall thickness, I have to remember to go in and also change the lip thickness. And maybe if somebody else is doing it, they're going to forget, and then the model doesn't work. So what do we need to do here? We need to, instead of saying that this lip thickness is 1, we need to say that it's what? You can put equations in here. I can say it's wall thickness divided by 2. Okay. Now, what's going to happen? If I change wall thickness, lip thickness is going to update to a value that will make the model work. So I'm giving the user great parameter, great freedom to customize the design, but constraining it such that no matter how they customize it, you're always going to get something that is going to work. Okay, is there anything else that you can see that we need to do? What else do we need to do? The corners are rounded. What is the radius of that curvature? So we would just say like corner radius. So we're going to say corner radius. Okay, and we're going to put that at 4. All right. Okay, I think that's all the parameters we need. Like I say, that took a few minutes because I'm explaining the concepts, but if you're just doing it, it's going to go just as fast by using parameters as opposed to just going in and just throwing a bunch of static dimensions at something. So what do we want to do? We want to draw a rectangle. So we come up, sketch, rectangle, 2-point rectangle. Hover over the origin, okay, snap to the origin, click, come out, click. Okay, what do? I dimension, I tap D, I point at this, I come up, and I want to put in 42, right? Wrong! No! I don't put in 42. What do I put in? This is the width. I use the parameter, okay? And then you see how it says fx, that's saying like something that you defined is 42. And then what do I put in here? 32? No! What do I put in? I put in length. Okay, now let me just show you real quick how this works. So if I came in and said instead of 42, I want this 52, look at that, it fixes it there. So I can go back and put it at 42. But you see now as we edit our dimensions, our drawing automatically updates. What do we want to do next? We want to fillet the edges. So what do? I come in, I get the fillet tool, okay. I'm going to say I want this and this to fillet. I want to fillet here and here. I'm going to put them all in, and then I'm going to go in and put the dimension because they're all tied together. And so, all right, now I get the select tool, and you see how this radius here? Okay, I don't want that 10. What do I want that? Corner radius. I want it a parameter. Enter. Okay, now look at this. Okay, now do you see how I'm getting more more things coming together here? All right, what do I want now? Well, if you think about the profile here, how many rectangles do I need? How many rectangles do I need? Well, let's see, this one's probably easier to look at. Okay, I have the inside of the lip, I have the outside of the lip, and then I have the outside of the whole thing. So there's 3. And this one that I drew is the outside of the whole thing. So now I need to just say, let's draw the inside of the whole thing. So what's the easiest way to do that? The easiest way to do that is with a offset. So I'm going to say offset, and I come in here and I say I want to offset this. And then how far do I want to offset it? I want to offset it -2. No! I want to offset it minus wall thickness. Okay? And then boom, look at that. Now this is a quirk, almost maybe a bug. I won't call it a bug because maybe they do it deliberately, because even though I put a variable there on an offset, it didn't take the variable. What did it do? It put the value of the variable. So I say, you've got to go in a second time and say this is wall. And since it's on the right side this time I don't use a negative sign. Wall thickness. Okay, enter, enter. Now you see how I have that fx. Now you can see that it's a variable. For some reason, offset is quirky and you've got to do it twice. So now what do I want? I want another offset. Okay, I'm going to come from here again. And then what do I want? I want minus lip thickness. Okay, then click OK. And now look at that. You see what happened? It did it again. So what do I have to do? I've got to click on that and say, you're forgetting. I want that lip thickness. Okay, now I've got the fx. Now this is a parameterized model. And so let's play around with this. Okay, so let's say that I come in and I want to change the corner radius to 8. Okay, boom, you see it all updates. All right, what if I want to change the length to, or the width to 52? Boom. You see everything holds together and everything works. What if I want to make the wall thickness 4? Okay, you see the wall thickness is right, but also the lip thickness is right. So you see this thing is really doing what I want. It's behaving in the way I want. Okay, I'm going to put these back. Where were we? We were at 42, and we were at 2, and we were at 4, because I think those are pretty good parameters for now. What's one thing that we don't like? This thing is jumping around. Why is it jumping around? Okay, what do we think? We think deliberately about dimensions. Did a good job there. Parameters, did a good job there. Position and constraints. What happened? When I rounded this corner, the constraint that kept the corner of this structure pinned to the origin, that point disappeared, so the constraint disappeared with it. This thing is out floating around like a crazy thing. We're not being deliberate about our position, so we need to put in some constraints. So what am I going to say? I'm going to say come in with constraints, and I'm going to say I want a coincident. I want this side to be coincident with the origin, and I want this side to be coincident with the origin, and now this thing is pinned down. Also look, now everything is turned black, and so that is saying that now that this is really fully constrained, that I've been precise with dimensions and been precise with positions. And if you look here on this sketch, you see how it gives me this little pin? It's kind of like a little star that says, good job, you've got your design completely constrained. There's no ambiguity in your design, and so that's good. I'm going to pull, I need to get select. I'm just going to clean this up a little bit. I like to get that where I can see it, get this a little closer. Okay, now this is completely done. Now we have a top and we have a bottom, and what your intuition would be is to select this, copy and paste it. But when you copy and paste, all of a sudden you start introducing ambiguities into your design. Like if you say this is related, this inside rectangle is related to this outside rectangle, if I cut and paste, well, is this inside one related to this outside one, or is this inside one related back to this one? So you see, all of a sudden there's a lot of ambiguities, and what I've found is things don't work very well if I copy and paste. And even though it's kind of the same thing, you could do like a rectangular pattern and have two go across and duplicate it, but even there I find some of the parameters don't come across in the way that I wanted. So I find it easier, I'll talk less this time, but I find it easier to just draw it again than use one of those two methods. And we can draw this pretty quickly, but we need to be deliberate again about our position. And so let's see, I think what I will do is I will come in and I will put a line, okay, and then I'm going to come out here, and then I'm going to come to here, and then I'm going to dimension it. Let's see, click the check mark, okay, and now get select, right mouse click, make this a construction line, and then what I want to do is I want to dimension it, and let's have that come out 65. Okay, and now what I've done is I've created myself a little place to design from over here, and we might have to lock it down to that in a minute, but at least I got kind of a place to go to. So what do I want? I want a 2-point rectangle. Okay, I come in this position and click. Why do I not have a 2-point rectangle? Rectangle, 2-point rectangle. Click, click. What do we always do? Dimension, type D, and then I come here, and this is 32. No, it's what? It's width. Okay, and then this is what? Click, come out, this is length. And I spelled it wrong. Click on that, enter. Okay, that's that. What do we do next? We put a fillet on it, so I'm going to say this and this, this and this, this and this, this and this. Okay, and so that looks good. What do I need to do? I need to dimension that corner roundness. So I come up here, select what we want, corner radius. Boom. Okay, what do we do now? We have two offsets. We come in and we do offset. I want to go from here. And what do I want? I want a minus wall thickness, enter. Okay, what did it do? Messed up again. So we put, this time, wall thickness, enter. Okay, what do I have? I've got wall thickness correct now as a variable. One more thing, I want to offset. So I come into offset one more time. Take this. I should not have, okay, offset. Click this, and then what is it? Minus lip thickness. Okay, and now what do? I got to tell it again, lip thickness, because of this quirk. And like I say, it might not be a bug. There might have been deliberate thought in why they did that. There might have been a good reason, but it kind of messes me up. Now look, because I constrained it to this corner and put a dimension on it, it's still showing this thing as a fully defined sketch, right? I've got the little push pin, that makes me happy. These things look good. Okay, we are ready to what? We're ready to extrude, but at this point things are fun, things are easy. Why? You win or lose the battle of Fusion 360 in the sketch domain. What have we done? We've been mindful of dimension, we've been mindful of position, we've been mindful of constraints, and we've been mindful of parameters. So we have defined a model that should always work. So let's do the fun part now. Let's start to extrude. I like to come to the kind of sideways view here, and let's start extruding. We get this extrude tool. What am I going to do? Start on the inside. If you start out here on the outside extruding, then you have trouble selecting the next part of the sketch. So I always like to start on the inside. I want to extrude this, okay? How far do we want to come up? We want it 2 millimeters, so I type in 2, right? No, it's what? Wall thickness, okay? And then okay. All right, we've got this, our sketch disappeared. Don't panic. Come over here to sketches. Do you see that light bulb turned off? Just click on it and it'll turn back on. Let's go ahead and do this one over here. Let's do this one. What is it? Wall thickness. Come here, say okay, boom. Now I want to do this one. Let's see. I want to do this one, and sometimes you got to kind of scoot in so it really selects it. All right, this is the bottom. This is the inside of the bottom. How high does the inside of the bottom come up? Top height? It comes up top height plus what? Lip height. Let's look at that. We can use equations. Wrong thing. We want to extrude. How high do I want it to come up? I want it to come up top height. Or, I'm sorry, that's bottom height, right? That's the bottom. My mistake. Bottom height plus what? Lip height. Bottom height plus lip height. Boom, look at that. That came all the way up. So that is this part from here to here is bottom height plus top height, and you get the whole thing. Okay, let's zoom back in. And then this one is going to be what? Can you tell me? Yeah, it's going to be just bottom height. Wow. Look at that. Right? That is Dunsky. All right, so now let's come in and let's do the top. Right, this, the inside one is going to be what? It's going to be just top height. Okay, so we're going to come up. We're going to come up how much? Top height. Okay, and then this one, we're going to come up what? It's going to be top height plus lip height. Does this make sense? If it doesn't, stop and go back and make sure you understand that. Top height plus lip height. Okay. Wow. Look at this. Look at that. Do you see that? Do you see how that's going to work? Do I have those? Yeah, maybe that's back. Okay. That looks really, really good. Okay, now where we are now is we're kind of like right back to where we were in lesson number 2. We have a nice design that we can go up and print. But let's say somebody comes in with glasses that are taller, you know, kind of like the big glasses. All right, what can we do? We can come in here and say, oh man, this needs to be 52. And this needs to be 40. Okay? And look at that. You see, we have adjusted it and we've changed the size, but even though we have changed the size, everything is still going to fit together. Now, what if we decided that, oops, with that dimension, we better put a little bit more lip on there to make sure that that lid stays on? Well, what we could do is we would come in and just change the lip height to 30. Okay. Now look, when we did that, look at what's really neat. This got bigger and the hole got deeper, but if we take the overall height of the assembled unit, it hasn't changed. We changed the lip. Everything adjusted the way we wanted. Okay, let's go back and let's put those back at our original 42, and let's put them at our original 32, and let's put them at our original 20. Okay, so that looks good. What if we looked at these and said, you know, that's really a little bit too sharp on those corners. I want to round those corners a little bit more. I could come in and I could say corner radius, instead of 4, let's make it 8. Okay, and ooh, look at that. Looks a little bit more rounded, not quite as sharp. That actually looks kind of good. All right. What if I got worried that these are a little bit flimsy looking, right? It's kind of flimsy. Is this really going to be strong enough? Well, what I could do is I could come in and say modify and say, let's make the wall thickness, let's make it 6. Okay. Ooh. All right. How does that look? Well, the good thing is it would fit together. It's still a functioning unit where everything's going to fit together, but it looks a little, it looks a little bit clunky there. And so we could come in and we could say, well, what I really want is I really want the wall thickness of 4. Okay, now that's looking kind of good. I think maybe let's go to a wall thickness of 3. Okay, do you see, guys, are you understanding that when I change the wall thickness, everything is adjusting? As I'm changing all these parameters, I am customizing. I have all the flexibility I need to customize this any way I want, but I have built into the design intent, to the parameters, something that will always print and will always work and will always come completely together, right? It'll always come completely together where there is no... This orange one seems to be kind of harder to see. You see, when it comes together, there's no seam. It fits perfectly because I've built into the definition of my parameters something that will make this always work. Okay, guys, man, if there's anything I hope that you guys got this lesson, because your life will be so much better if you design thinking with intent and thinking how your design should fit together. Like, imagine if you're making a Raspberry Pi case, what is always going to be fixed? The dimensions between the holes on the Raspberry Pi, those mounting holes, those you would want to put in as fixed parameters, and then what might change is this or this or this, but you would be thinking of that Raspberry Pi box based on how this needs to always work. The Raspberry Pi always needs to fit in, and the screws always have to be in the right spot, but maybe I would want it thicker, maybe I want this and that. So thinking about the things that you want to build in as constraints, kind of parameter-based constraints that you build in, sort of like our lip thickness is half of the wall thickness. That keeps us out of trouble. Man, I hope this has been helpful for you guys. It's like really, really, really important. Let's think about what we've learned. You win or lose the battle in the two-dimensional sketch plane. Okay, did you see once we defined things properly in the two-dimensional sketch plane, everything else was fun and easy and worked great? In the two-dimensional sketch plane, you are mindful and you're deliberate about dimensions and about position. Use constraints as your tool, as your friend. Understand constraints. So we have constraints, we have dimensions, and we have position. And then what do we use? We use parameters to create a device that is highly customizable, very easy to customize, but no matter how we customize it, we always end up with something that works. I would love to hear your comments down below. Man, I am not a mechanical engineer, and this is not going to replace a 4-year mechanical engineering degree. But just as us home hobbyists and us guys having fun, I think that if you will use parameters, it'll make your life a lot easier, because you won't have to keep going back and starting over from scratch and redesigning something when you want to edit it. Love hearing your comments down below. I read every comment. I try to respond to as many of them as I can. If you like this video, think about giving us a thumbs up. Okay, think about sharing this with other people. Bring some more people into our little family channel here. Okay, our family friendly channel. Bring people into this, and then also think about giving us a thumbs up if you like it. Paul McWhorter, TopTechBoy.com. I will talk to you guys later.